Hi dear, last class we have seen what is covalent bond, what are the types of covalent bond as well as the properties of the covalent bond. Okay, so today we'll see important things that we should know. Okay, that is allotropes of carbon. Okay, first we'll see what is allotropy. Okay, then allotrope and allotropes of carbon. Okay, allotropy. Allotropy means the property by virtue of which an element can exist in more than one form. Okay, any one element which exists in more than one form is referred to as allotropy. Okay, it can exist in more than one form, that is called allotropy. The various forms of an elements which have similar chemical properties, what we call is it exists in more than one form, right? That means what? It has similar chemical properties. It will have similar chemical properties but different physical properties. Okay, because it exists in some other form, no, only the physical structure will vary but the chemical properties remains the same. Okay, that we call it as allotropes. Okay, we'll call it as allotropic forms or allotropes. Okay, so what is meant by allotropy? It has more than one form which has different physical properties and similar chemical properties. Okay, so allotropes of carbon. The allotropes of carbon is exist in three different forms. The crystalline form is this crystalline form of allotropes are diamond and graphite. These two, diamond and graphite, are the allotropes of carbon. And in amorphous form, that is not crystalline in nature. Okay, it does not have any structure. So that is coke, charcoal, etc. etc. Okay. Then fullerenes form another class of carbon allotropes. Okay. So we are going to see in detail about this diamond and graphite only. So amorphous, this is not required. The fullerenes alone will see some of the few points. Okay. So it is named after a architect, Buckminster Fuller, who designed a geodesic dome. Okay, the structure of this fullerenes, this carbon will be like the dome. Oh, he has designed one dome, geodesic dome, right? So it looks like that. Okay, so this uh, that's why it gets the name fullerenes. Okay, it is first identified in the form of carbon 60. Okay, carbon 60. Here the carbon atoms are arranged in the shape of a football. See, this is your structure of C60 Buckminster fullerenes. Okay, so it will be arranged like this. Okay, this is how he has designed this dome also. Okay, so it gets the name Buckminster fullerenes. Okay, C60 carbon. Okay, next we'll see about the diamond. So because of this different in the physical nature, it got different properties. There's a graphite as well as diamond. Totally it is different. It has different physical properties. Okay, based on the structure. Okay, so we have to see what is the type of structure in the diamond and graphite. Okay, structure of diamond. You know that carbon valency is 4, right? So how the structure is formed here means each carbon atom is covalently bonded to 4 other carbon atoms. So a carbon is this, so it has a 4 valence electron, right? So each carbon atom is bonded with the another 4 atoms. Okay. So here one carbon atom, here one carbon atom, here one carbon atom. Again this carbon atom will combine with the another 4 carbon atoms. So it gives rise to a rigid 3-dimensional structure. Okay, strong 3-dimensional structure. Okay, so it will be looks like that. This is a carbon and it is connected to 4 carbons. Again this carbon is connected to another 4 carbon likewise. Okay, so it gives rise to a 3-dimensional view. Okay, 3-dimensional structures. So what are the properties of diamond? It is crystalline in nature. We have already seen that. It is the hardest substance known. This is the hardest substance in the earth, right? It is a non-conductor of heat and electricity. Okay. It can also be produced. Okay. It can be synthesized by subjecting pure carbon to very high pressure and temperature. If you put the pure carbon into very high pressure and temperature, you will get a diamond, synthetic diamond. Okay. Then what is the difference between the synthetic diamond and natural diamond? The synthetic diamonds are very small compared to the natural diamond. Okay, otherwise it will be yeah, otherwise there is no difference between the synthetic diamond and natural diamond. Only difference is synthetic diamonds are very small when compared to the natural diamond. Okay, these are the properties and structures of the diamond. Okay, next one is your graphite. So here graphite, here based on because of the structure only the properties differ, and diamond is the very hardest material, you know, and this graphite is, no, it is very smooth and slippery. Okay, the structure of graphite, each carbon atom is bounded to three other carbon atoms. Okay, it is bounded to three other carbon atoms in the same plane, giving a three hexagonal array, giving a hexagonal array. Okay, it forms a shape of hexagon. Okay, it is connected to three carbon atoms, but the valency of the carbon is 4, right? So what happens to the another one? One of this bond is double bond. Here it is connected to three atoms with the one of the bond is double bond, so all the 4 are satisfied. Okay, and thus the valency of the carbon is satisfied. Okay, it is bonded to three carbon atoms, in which you know that the covalent bond, single bond is represented by single line. Here one of the bond is double bond. Okay, so it is represented by the double line. Okay, one of these bond is double bond, and thus the valency of the carbon is satisfied. Okay, it is formed by the hexagonal array being placed in layer one above the other. It will be look like that. It form a hexagonal shape. Okay, hexagonal shape, and it will be layered. This is one layer and this is another layer. One above the other it will be placed. Okay, so if you look at the book, it will be like this. Clearly, this is the structure of the graphite. Hexagonal array arranged one above the other. Okay, this is the structure of the diamond. Each carbon atom is connected to other 4 carbon atoms. Okay, here one of the bond is double bond. So what are the properties of graphite? Graphite is a smooth and slippery element. Okay, graphite is a good conductors of heat and electricity. Usually non-metals are bad conductors or poor conductors of heat and electricity. The exceptional case is graphite. Graphite is a good conductor of heat and electricity. Because of this structure, these properties will vary. Okay, thank you.